paper, we looked at intelligent writing support. Our aim was to study how targeted support influenced writers. To target the support, we used Flower and Hayes' well-established cognitive process theory of writing. This theory describes different cognitive processes involved in writing. We targeted some of these processes using a support tool based on a large language model, namely OpenAI's GPT 3.5 Turbo. What we found was that we can prompt the large language model to support the cognitive processes described in the theory. This results in intelligent, relevant support to the writer. This support seems to directly support the cognitive processes we targeted. We found that writers did not simply use the support to speed up their writing, even though they were paid to complete their writing tasks. Instead, support led to more engagement with the writing task, meaning that they tended to spend more time on completing the task than they would have without support. This is why we titled our paper, Intelligent Support Engages Writers Through Relevant Cognitive Processes. We are very pleased to present you our research. I am Andreas Göldi from the University of St. Gallen, and my co-authors are Thiemo Wambsganss from Bern University of Applied Sciences, Seyed, Parsa, Neshaei from the Swiss Federal Institute of Technology in Lausanne, as well as Rietsche, also from Bern University of Applied Sciences. In this talk, I will first give you a short introduction to the domain we test our intelligent writing support tool in. That is the domain of student peer review writing. Then I will proceed by introducing the cognitive process theory of writing, which we used as the backbone of our research. I will then present our tool before going to the methods and analysis of the study we report on. Then follow the hypothesis and our findings. After having established the quantitative results, I will tell you a little on the user feedback and design implications that could be interesting to some of you. And finally, I will try to encapsulate everything in a take-home message. Student peer review writing is a collaborative learning activity that is important, especially in large-scale education. It involves students critically evaluating and providing feedback on each other's written works. This process is not just an academic task, it helps to practice critical thinking, fostering a deeper understanding of subjects and motivating learning. The support of the writing process within peer review contexts holds significant importance. It serves to amplify students' engagement with the material, transitioning them from passive recipients of information to active participants in the learning journey. Moreover, it cultivates essential skills in evaluative and constructive feedback, which are important not only within academic realms, but also in professional settings. Traditionally, writing support has taken different forms, from instructor-led manual feedback to technological tools. These methods, while effective, often concentrate on formal aspects of writing, grammar, punctuation, and style. Technological advancements have introduced tools that help with more content-oriented aspects as well. However, before the rise of large language models, it was very difficult to build writing support tools that could truly fulfill the label intelligent. One of our goals with this research project is to understand how to make use of this powerful technology, not only to automate, but to support writing. Especially in domains such as student peer review, writers tend to experience writer's block or are often overwhelmed. Our research aims to help here and introduces an approach through a large language model-based tool that transcends traditional boundaries of writing support. Harnessing the capabilities of large language models, our tool provides a level of intelligent writing support that goes beyond syntax and stylistic recommendations. Grounded in the cognitive process theory of writing, it actively supports key cognitive activities involved in writing, such as ideation and the critical evaluation of content. The cognitive process theory of writing divides the act of writing into two fundamental aspects. We have priors and cognitive processes. Priors are the bedrock of writing, akin to the canvas for a painter. They include the writer's long-term memory, which encompasses the understanding of the subject, the audience, and the purpose. Essentially the what, to whom, and why of the writing task. Alongside this is the text produced so far, which acts as a roadmap showing where the writing has reached, and the rhetorical problem, guiding the direction the writing should take to achieve its purpose. Moving on to cognitive processes, these are the dynamic steps a writer takes while crafting their piece. Planning involves setting goals, generating ideas, and organizing thoughts. Translating is the act of articulating the planned ideas into coherent text, the bridge between thought and expression. Reviewing, the final process, involves critically evaluating the written text and revising it to refine and polish the piece to its final form. Some of these processes are exploratory, adding information. Some are exploitative, using information to change the text itself. Most processes belong in the former camp and are exploratory, for example, ideation or evaluation. Translating and revision change the text itself and are exploitative. Crucially, these processes are not in a static chain from start to finish, but occur in a loop, with each process returning to prominence then and again until the text is fully written. We use two minimal cases where we have switches between the processes, but in a very controlled fashion. In task 1, there is a switch between ideation and translating the ideas, and in task 2, we have the same switch between evaluation and revision. Namely, we have a tool with two variants, one for each of the tasks. For the ideation translation switch, we have a page with instructions. These instructions are: imagine you're working on a project or assignment and you're eager to obtain feedback from your professor before submitting it. However, the other members involved in the project do not share your belief and do not want to gather any feedback. In a 250-word text message, try to convince them to change their minds and participate in seeking feedback. Begin by explaining why you value feedback and how it can improve the quality of the submission. The user then writes in a simple text editor. In the support groups, there is a button to get example ideas to put into writing. For the evaluation revision switch, we had an analogous setup, only with a different instruction, support button, and prompt. Here, it was all about reviewing the text. The tasks are fairly simple. Task 1 can be encapsulated as write a convincing message to your peers. This is not the full package we need from an actual student peer review, but it is a crucial aspect, and we tried to make this task as simple as possible so as not to introduce any confounding influences. The instruction already provides most results of the planning processes described in the cognitive process theory of writing. It provides a goal, and the text is so short that organization is not as important as it otherwise surely is. We therefore concentrate on only the remaining planning process, ideation, which is supported by the tool. Similarly, in the second task, we support the evaluation process by providing feedback on the written text. What did we expect from this setup? How would users use the tool? We had 4 hypotheses. H1, comparing intelligent support and static support for writing, the time people spend on ideation and translation differs significantly between the groups. H2, comparing intelligent support and static support for writing, the time people spend on evaluation and revision differs significantly between the groups. H3, there is a decrease in the use of intelligent ideation support if static ideation support is present. And H4, there is a decrease in the use of intelligent evaluation support if static evaluation support is present. The rationale for our research design was to allow so-called monitor activity. Monitor activity is the already mentioned switch between cognitive processes. Namely, the monitor process is used to decide which process is next. The switch between processes is essential to writing but to turn the research design as simple as possible, we constrained it to two processes. In the first task, ideation and translating, in the second, evaluation and revision. As independent variables, we varied whether participants received support and whether they received a static idea or evaluation, that is the result of the cognitive process they had to engage in. We had 120 participants recruited from the platform Prolific with a mean age of 33 and about 70% male. We had 4 groups in our 2x2 factorial research design. Group 1 received neither intelligent support nor static results of the relevant cognitive processes. It served as the control group. Group 2 did receive intelligent support. Group 3 did not receive any support, but was provided with static ideas and evaluations without clicking any button. Group 4 received both support and results. As dependent variables, we assessed time spent and button use. The buttons provided triggered the generation of support coming from the large language model. Let's go to our findings. Users spent longer engaged with the text if they had support available. This is important to digest since we could think of support merely speeding up writing. That is not the case, at least for supporting the exploration processes we did in this study. The number of button clicks for groups 2 and 4, which received intelligent support, shows that support is used only if it is needed. This means that we need to tailor support, in our case writing support, to the actual needs. Simply making support available will not result in high use or value creation. This is why it is important to use theory to understand what processes are involved that can be supported. This is underlined if we turn to the hypothesis tests. The tests for H1, H3, and H4 were significant. H2 was not. It postulated that time spent should be different depending on support in task 2, that is the evaluation revision task. The significant result for H1 shows that this difference is observable in the ideation translating task. Looking closer at task 2 and H2, we find that the time spent on the task only increased if the presence of intelligent writing support led to more switches between exploring evaluations and implementing them as revisions on the page. Finally, I want to present you with some of our users' feedback. This will be especially helpful to those of you who are interested in writing support tools. I have to keep this short, but want to give some findings. A finding that will be familiar to all who study or work with writing support tools is that users tend to want more specific suggestions. We believe that targeting the cognitive processes writers are engaged in directly will help with this already. However, the large language models have to be prompted and used in the right way. As our users also wanted more diverse suggestions to choose from, one possibility would be to make use of randomness parameters of large language models such as temperature. We also found that the standard writing support tools of previous generations are still very much desired. While intelligent support can now go beyond grammar, syntax, and style, users are used to having help with these aspects and they struggle without it. To make a long story short, when users have access to relevant support tools, they are more inclined to keep engaged with writing tasks for longer. However, if results of cognitive processes are provided outright without requiring any mental effort, users tend to stick with them instead of using support to come to their own results. From this, we infer that intelligent support isn't just about speeding up the writing process, it actually makes users more involved with their text. For support to be truly effective, it must be tailored to what users need. This is where theory comes in, particularly the cognitive process theory of writing, which can guide the development of intelligent writing support. Such intelligent support, especially when offered by large language models, significantly boosts user engagement with the writing task. I hope you enjoyed this talk. Please get in touch if you have any questions, comments, or if you see potential for collaboration. I am Andreas Göldi. My co-authors are Thiemo Wambsganss, Parsa, Neshaei, and Rietsche. Thank you.